Finishing up this problem, hopefully you've had a chance to factor that out. If not, take a second and factor it out. I'd like for you to check it with what I have. So I got this to factor into 2 cosine x minus 1 times cosine x minus 1. From there, I'm going to set each of these equal to 0. Over here, I'll add my 1 over and divide by 2. Over here, I'm just adding my 1 over. Once I have the cosine by itself, I'm just looking at my unit circle and trying to decide where does cosine equal, in this case, a 1/2. So that's my x value. Cosine would be 1/2 up there at pi over 3 and down here at 5 pi over 3. Since it says find all solutions, I'm going to have pi over 3 plus 2 in pi and 5 pi over 3 plus 2 in pi. For cosine equals 1, that's my x value of being 1, which would be over here at 0 or 2 pi. We always want to choose the 0 here, because when I say 0 plus 2 in pi, oh, now 2 in pi is included. So those are my 3 answers. I will say this last answer here, that 0 plus 2 in pi, you could simplify that a little bit and just list that as 2 in pi. Either way, you have 0 as one of your answers, and then I'm adding 2 in pi to that, because if I added 2 pi 0 number of times, oh, I just have 0. So it does still work. Either way you want to write that one is fine. And number 7, you're finding your solutions in that interval of 0 to 2 pi. First thing I noticed right off the bat, that my trig functions don't match. If one of them was squared, then I would say let's try to rewrite it using the other one with my Pythagorean identities. But neither one of them is squared. They're already sine and cosine, so I can't really rewrite them into each other. So my only real option to get these to match up is going to be to square both sides. Do be careful. When you square this left side, you're not doing cosine squared plus 1. You're doing cosine x plus 1 times cosine x plus 1. So that's going to give me cosine squared x plus 2 cosine x plus 1. And if you need to come over to the side and FOIL that out, that's fine. Over here, I'm going to have sine squared x. Now, they don't match still, but when they're written with squareds in them, I can rewrite one of them as the other using those Pythagorean identities. Since over here I have cosine squared and cosine of x, I want to rewrite this sine squared is 1 minus cosine squared. And if you're not sure how I did that, your Pythagorean identity says sine squared x plus cosine squared x equals 1. I wanted to get the sine squared by itself, so I subtracted that cosine squared over. So sine squared x equals 1 minus cosine squared x. So I can just replace that 1 minus cosine squared x where my sine squared x is. I didn't change anything on the left side. Now my trig functions match. I just need to get them all on the same side because this will set me up nicely for a quadratic. So I'm going to add my cosine squared over. So I have 2 cosine squared x plus 2 cosine x. My 1's are actually going to cancel, so equals 0. And still factor here. I can factor out a 2 cosine x. I'm left with cosine x plus 1. Something times something equaling 0 means I set each of those equal to 0. So here I'm going to divide by 2. Cosine is 0, or my x value is 0, up here at pi over 2, and down here at 3 pi over 2. So I have pi over 2 and 3 pi over 2. Over here, I'm going to subtract my 1 over. Cosine is negative 1, or my x is negative 1, over here at pi. So I have pi as an answer now. And like I said in that first video, a lot of the times these will be written in the order from least to greatest, but as long as you have all of your answers listed out, that is fine. All right, on number 8, the biggest thing that's happening here that's different is this 3t. We're used to just having a t or an x or a theta or whatever. What that does, it doesn't change anything you've done so far, but that means that you are always going to need that plus n pi, or sorry, plus 2n pi. If it was tangent, it'd be plus n pi. Sine is plus 2n pi. So anything happening inside that trig function, sine, cosine, tangent, whatever it may be, whether it's cosine of 3t, maybe it's sine of x over 2, or tangent of 3x, you have to have, in this case, this plus 2n pi. If it was tangent, you'd have plus n pi happening. So that's the only way you're truly going to account for all of your answers, whether it says all solutions or not. If it's still said between 0 and 2 pi, you have to do this. So over here, I'm going to add my 1 over, divide by 2. I need to get inside my trig function, so I first need to do the trig. So cosine is a half. Up here at pi over 3, and down here at 5 pi over 3. So those are my two angles. Again, but this is an x. This is 3t. So that means 3t equals pi over 3. And 3t equals 5 pi over 3. This is the point where you need to add your plus 2n pi. And then you're still solving like you normally would. So I'm going to divide everything by 3. So t pi over 3 divided by 3 is going to become pi over 9. 2n pi divided by 3 is going to become plus 2n pi over 3. Same thing over here. Divide by 3. T equals 5 pi over 9 plus 2n pi over 3. Now it says all solutions. So these are my answers with that 2n pi over 3 still listed out. If it said all your solutions between 0 and 2 pi, you're going to start with your pi over 9, and then you're going to add 2 pi over 3. So if you need to do it off to the side, pi over 9 plus 2 pi over 3. Oh, I need a common denominator, which would be 9. So that's going to become 6 pi over 9. Okay, that's 7 pi over 9. If I add another 2 pi over 3, so I'm at 7 pi over 9. If I add another 2 pi over 3, that would be 13 pi over 9. I'm going to take my 13 pi over 9. I'm going to add another 2 pi over 3. That gives me 19 pi over 9. This one causes a problem because 19 over 9, that's like 2 1/9. If I'm going only to 2 pi, that's too big, so that's how I know to stop. So I have these 3 answers from this one. I'm also going to have some answers over here. So 5 pi over 9, add that 2 pi again, it's going to give me 11 pi over 9. Add another 2 pi over 9 is going to give me 17 pi over 9. If I added another 2 pi over 9, that'd give me 23 over 9, which is too much. So those would be my answers if I asked for your solutions between 0 and 2 pi. So if they are asking for your solutions between 0 and 2 pi, you do have to list them out. Here, we're looking for all solutions of 3 tangent of x over 2 plus 3. So all this does is nothing at the beginning, but it means I'm going to need to have plus n pi happening. And it's just n pi because it was tangent. If it was cosine, it'd be plus 2n pi. But I still start the same. I'm going to subtract my 3 over. I'm going to divide by 3, so I need to know where does tangent equal -1. Since tangent is my y over my x, first if I'm getting negative, then I either need to be in quadrant 2 or quadrant 4, because that would be where one of them is positive and the other one is negative. To get a -1 means that they're actually the same. It's like those radical 2/2s, just one positive, one negative. So that happens at 3 pi over 4 and 7 pi over 4. So I'm going to take my x over 2, I'm going to set it equal to 3 pi over 4 plus n pi, and that's because of the x over 2. I'm going to do the same thing with my 7 pi over 4. To solve this is x divided by 2, so I'm going to multiply both sides by 2. So once those have canceled, I have x here, 3 pi over 4 times 2. If you need to think of that as 6 pi over 4 to start with, or if you can just straight reduce it, that's fine, but 3 pi over 2 plus 2n pi. Over here, I'm going to also multiply by 2, so I'm going to end up with 7 pi over 2 plus 2n pi. If I had asked for your answers between 0 and 2 pi, you would have started with that 3 pi over 2. If I add 2 pi to that, so 3 pi over 2, I want to add 2 pi, so it's like 4 over 2. That gives me 7 over 2. 1, that's what I already have listed here, so that does make this side a little bit repetitive, because this just automatically got me to 7 pi over 2, and then I would still be adding 2n pi on top of that. But also 7 over 2 is outside of that range from 0 to 2 pi, so if that's all I had asked for, you would have stopped right there with your answers. Since I did ask for all solutions, you want to keep it as the 3 pi over 2 plus 2n pi. This is set up nicely for a quadratic, however my trig functions don't match here, so I do need to try to rewrite them so that they will match. So I can rewrite secant squared is 1 plus tangent squared of x. I would then want to get everything in my normal quadratic order. So tangent squared minus 2 tangent x. I'm going to go ahead and subtract my 4 over, so I get minus 3 there. Need to factor this, so numbers that multiply to -3 and add to -2. I'm going to have tangent x minus 3 and tangent x plus 1. Since that's something times something equaling 0, I can just set each of these equal to 0. This tangent x equaling 3 looks a little bit questionable, so I'm going to skip it for a second and come over and do tangent x equal -1. We actually just did something like that, and I know that that happens at 3 pi over 4 and 7 pi over 4. So those are my two answers over here. For this one, this is not on my unit circle, so I would have to do my arc tangent. So it's not on the unit circle. So x equals arc tan of 3. Do make sure you have your plus n pi, because I did ask for all solutions. That's giving me about 1.249 plus n pi. So for my answers, I would have 249 plus n pi, and that will just keep adding pi over and over and over. For this, I don't need to have the plus, I don't need to have both of them, because I do 3/4 plus 1, I'm going to get 7/4. So you could leave it as the 3 pi over 4 plus n pi. However, because you did have to do arctangent over here, sometimes you will see it as if you had done arctangent on this side. So to get to that 7 pi over 4, that would actually be a negative pi over 4 plus n pi. So that would be a possible way to see those answers there.